All right, so we're going to go a little bit deeper into correlations in this video. This is a really important video. So for starters, we have these three graphs here. They're showing you positive correlation, negative correlation, and no correlation, okay? So for starters, positive correlation, as X increases, Y also tends to increase as well. So we can see that here. We also saw that in the Kobe Bryant data. As the minutes played increased, the points tend to increase. So that is a positive correlation. A negative correlation is just the opposite, as this independent variable increases, the dependent variable tends to decrease. So Y decreases as X increases, and then no correlation is there's no estimating. You don't know if X increases, if Y will increase or decrease. We don't really know because the data is so spread out. Okay, so those are our three different types of correlations. Okay, and then we have what's called a correlation coefficient. A correlation coefficient so if we look at correlation tells us the relationship between two variables. Okay, so we can see if it's a positive, negative, or no correlation. Okay, there's no relationship. And then the coefficient tells us the strength of that relationship. Okay, so our correlation coefficient here, okay, is a 1, and the coefficient is between -1 and 1. Okay, -1 if it is going, if it's a negative or negative correlation, of course, and then a positive 1 if it's a positive correlation, of course. Okay, but all I'm wanting you to know here is that a 1 means that the line's really tight. Okay, it looks like almost a straight line, even though it's a scatter plot. Okay, and then this one is becoming a little weaker because the points are a little bit more spread out. So this correlation coefficient is a little weaker, and then this one's a 0.4. It's even weaker yet, but it's still positive. It still tends to increase. Your your Y tends to increase as your X increases, but it's positive, but it's not as strong as this one. And then this one's no correlation because we don't really know what's happening. Okay, and then these are just the opposite, but just with negative correlation. Okay, all right. So then we're going to look at trend lines. Okay, so I have here MLB data and salary. Okay, so I took for the last 30 years, 1985, 2015, I plotted all of every single one of MLB players' salaries, okay, here. And we're going to look at the three different types of trend lines and go over that real quick. All right, so if we look here, I have the same data set here, okay? So again, I plotted every single one of the player salaries, so 1985, 86, 87, 88, 89, 90, okay? And if we see here, I'm going to plot a trend line. A trend line is like your linear regression, remember? Okay, and it looks like if we plotted a trend line of a linear trend line, it would be going through here, right? And remember, this is a scatter plot. It doesn't look so scattered because all the points are pretty grouped together pretty closely. Okay, and a linear trend line would be a straight line. But this here looks like to me that it's going to be an exponential trend. Okay, and it does look like it's kind of increasing exponentially. Okay, as the years increase, salaries increase, but they start to increase at a faster rate. Okay, salaries are increasing a lot faster as we go up. So I want you to know that there's different types of trend lines. We have linear trend lines, exponential trend lines, quadratic trend lines, and they all are going to be a little bit different. Okay, but we can choose trend lines by looking at the data. Okay, so again, there's no relationship with this, so there's not going to be a trend line, but we could do a linear trend line. It would have if it had a linear relationship, if the relationship like this. Okay, a quadratic, I don't know why they spell it with a C, but a quadratic trend line, if the relationship kind of looks like this looks kind of like the arc, the scatter plot of that arc of Kobe's shots. Okay, and then an exponential trend line is something that kind of increases very rapidly. You see, it's kind of flat, and then it increases very rapidly, like the MLB statistics. This linear trend line would be more like the Kobe's minutes plays to points scored, and then a logarithmic trend line and an inverse relationship. I don't expect you to really know exactly what trend lines to choose, but I want you to get familiar with them, okay? Especially with the linear trend lines and the exponential relationships, okay? And kind of understand that not every scatter plot is going to have a linear line. Most of them do. Some of the relationships are going to be exponential, okay?